name's Josh. I was a computer science examiner for multiple exam boards, head of computer science in UK-based schools, and now I run a tutoring business where I've helped a lot of students to get better grades in computer science-related courses. And today's topic is all going to be to do with adding normalized floating point numbers together and subtracting them. And what I was thinking I was going to do is to hopefully see if this is going to make things easier for you, is by putting some steps of how to do it, because I'm not going to lie to you, there's quite a lot of steps on this one. So I'll talk about the fundamentals of this. Let's say that we had two numbers in standard form in maths. You couldn't just immediately add those together. You'd have to normalize them, work them out like so. And then once we have done that, then we can add them together. And the principle is exactly the same with what we're going to do, even though it's in binary, is then we have to move the decimal point, rewrite them, and then we can use binary addition to add them. So that's the general gist of what you're trying to do, is you move the decimal point and then perform binary addition on them, and then, normalize the number, and then that is going to be your answer. Again, little note for you. If you just convert these numbers and just move them and actually work them out as denary numbers and then convert them back into floating point, they don't like that. So I'll show you how to do it the correct way. So first of all, we just have to use the exponent to move the decimal point. So that's step 1. So that's going to be 2 on that one, and that is going to be 4 on this one. So we go 1, 2, draw our number. Could put more zeros, but it's just going to be a waste of time. So the decimal point is here. And then what we are going to do is we then need to move this one 4 places. So that's going to be 1, 2, 3, 4. And now the trick is on this one is look at where the decimal point is at the one at the top, and look at it is where it is on the bottom, and just make sure that you match it up with the correct numbers. That's where I probably see most of the mistakes happen, is people put them in the wrong place. I put a little 0 here as well, just to help me keep track, and then you just put the other ones in there. Okay. Now, once this is done, all we have to do is we just add them up using normal binary addition method. So 1, 1, 1. Put the decimal point there just to help you, remind you. 1, 1, 1, 1. Now with positive floating point numbers, what we have to do is we have to make sure that we've got a 0 at the front, because if it's to signify to the computer and us that it's positive, it has to go 0, 1. If it was negative, it would be 1, 0. Now, what we are going to do to work out the exponent, so this is step 3, which is move the decimal point in between the first 0 and 1. We're going to go 1, 2, 3, 4. Redraw our number like so, and then the 4 tells us that we've moved it 4 places. So all we're going to do is our exponent is going to be 0, 1, 0, 0, and that there is a completed how to add the two numbers together using floating point binary addition. So that there's your mantissa and there's your exponent. Now, the second thing that we need to do is we need to be able to do a subtraction of them, which is slightly more complicated, because what we have to do is we use that rule, when we were learning about the binary subtraction. If you haven't seen that video, please go and check that one out. And what it is all to do with is that we use the rule that plussing a minus number is the same as just minusing a number. So we are going to 2's complement the second number, and then we are going to add that on to the other number using exactly the same method as we did before with the addition, but all it does is it just means that we don't have to learn any different rules for binary subtraction. We can just use the rules we already know for binary addition. So these are the steps. First one is going to be 2. So what the exponent. So what we do is we just move that 2 places to the right. So 1, 2, and then we redraw our number. So I'll just put in the 0, 1, 1, decimal point, very important, and then you just put 0, 0, 1. I could put more numbers in there, but they're not going to have any bearing on what the final answer is, so I'm going to leave them out. Now this is 3, and then what I actually need to notice here is because there is quite a lot of numbers here, and the more you do this, you will just naturally get better at this. The answer that we're going to get is going to be a negative number if we've done this correctly, because this is actually, you can see that the number we're taking away from the number above is actually going to be bigger. So when I move this, once I've 2's complemented it, or I mean, you can even see it as a positive number. If I move that 3 places, so 1, 2, 3, that's going to give me 5.5. While this is I can see very quickly this is just going to be 3 point and then 125. So if we've done this right, we should get a negative number, which if for a negative number, it needs to have 1 0 at the front, which is very important, because if you try and make it 0 1, that's going to signify to the computer or you that it's a positive number when actually the answer needs to be negative. So let's have a little look at this. So first of all, I'm just going to 2's complement this. So technique, going from right to left, and we go everything at it and before it stays the same. I could write zeros in, but again, they're going to have no bearing on what it is that we're actually doing or for the answer. So I just put in those numbers here, 1, 0, 1, and then I move the decimal point now, so it's going to go in between there, 1, 2, 3, just there, and we just start putting in the numbers and make sure that you match it up in the correct place, because that's going to be a very, is a big probability that that's where people get things wrong. So 0 and then 1 there, and I'm just going to put the 0 in at the end as well. Just going to move this up here as well. So then all we do is we just put in the numbers like so, and then we're just going to put a 1 there, and I'm going to put 0, 0. Okay. Now we just put in our normal binary addition. So we're going to go 1, 0, 1, decimal point, 1, 0, carry the 1, 1, 1. Okay. Now, different part here is because we're going to get a negative number, we are not going to put it into the 0, 1 position. We're going to put it into the first 1, 0 position. So this one is going to be here. So we're going to go 1, 2, because that is the 1, 0 that is furthest on. If we tried to put it here, it would be 1, 1. That doesn't work. If I went any further, there's going to be no situation where it's going to give me 1, 0. So that's the latest 1, 0. Once I've done that, I just redraw my number. So this completely gets truncated and forgotten about. And then I'm just going to put in 1, decimal point to help remind me, 0, 1, 1, 0, 1. And because I've moved it 2 places, all I have to do is I just have to remember that my exponent needs to be 2. So 0, 0, 1, 0. If the answer is asking you to put the mantissa in a particular number of bits, you just know that you're going to put it in terms of 0, 0. So if it was 8 bits, you'd just add in the correct number of zeros. And that's how you do it. So it's just looking about for those particular features. And that's how you do binary addition and binary subtraction.